Okay, in this video we're going to talk about one more way to graph linear functions. And when I say linear, I mean there's an x and there's a y, but we don't have any exponents other than 1 to deal with. Now this one's kind of scrambled up. You can see it's written in what we call standard form, which means the x term and the y term are both on the same side of the equation. And we're not used to working with it that way, maybe. I mean, a lot of times you see these things written like this, or we try to make them look like that. And we could certainly do that with this one. We could move the 2x over, we could move the 3 over, and we could make it fit that. But if you'd like to avoid doing that algebra, we don't have to approach it this way. Okay, what we can do is what we call an intercepts chart. And when I say intercepts, I mean, I call it a zeros chart. I want to know what value happens if one of these variables is 0. So for example, if I make the x 0, what is y? And on the other side, if I make the y 0, what is x? And it'll give me 2 points. And what it'll tell me is, where does it cross the y-axis and where does it cross the x-axis? And if I know those, I can connect them up and I have my line. So here's how I start it. Usually we have a table of values that we do with lots of things. We put lots of different points in for x. In this case, I'm going to do it like this. I'm going to put 0 in for x and 0 in for y. I'm going to get 2 values here. Okay, so if I put 0 in for x, watch what happens here. 2 times 0, and I'm getting that from right up here, okay, minus 3 times y equals 12. Now, if I go to calculate that, that's going to tell me, well, watch what happens here. 2 times 0, that's just 0. All of a sudden I have this simple thing to calculate. Negative 3 times something equals 12. So I divide by negative 3. And what I find is that y has to be negative 4. Okay, so that's 1 point I can find on this. Right here, 0, negative 4 is at 0 on the x-axis, negative 4 on the y, right down here. Okay, now let's do the same thing from another perspective. Let's use green this time. From another perspective, let's try putting in 0 for y. Well, this would give me 2x minus 3 times 0 equals 12. Notice it's the exact same equation I did before, but now I put in 0 in the y place instead of in the x. Now what that does is it makes this term right here equal 0. So I've got 2x equals 12. That must mean if I divide by 2, I'm going to get x equals 6. So 6 goes with that one. Now let's find this spot right here. 6, 0 would be 1, 2, 3, 4, 5, 6. Would be way over right about here. And if I connect those, there's my straight line. Okay, now that's the exact same line I would get if I took my original function and made it look like y equals mx plus b. I would get the same line. I might have different points that I calculated and found on that line, like this point right here or this point right here, but it would still be the same general line in the same spot on the graph.